Hello, guys. Thank you for joining us in this first edition of coding challenges overview and solutions. We want to look at some technical questions asked in interviews. Usually, when you apply for software engineering role, probably front end as a front end developer, back end developer, DevOps, or whatever, you'll be required to put your skill to test before you get the job. And one of the questions I've come across in the past year is this: a word weight. The question goes this way. Let's look at it critically. Starts with, okay, let me put this in perspective. Okay, all right, okay. Starts with a character's corresponding integer is equal to the position of the character in the alphabet. Given a word S and an integer N, you need to apply the following steps in the order and return the resulting integer. First step is replace the characters in the word S with the corresponding integers. Pass the result in the integer to the next step. Sum of the digits of the integer. I want you to pay attention to this. Digits of the integer. That's what you're summing, not the integer. Repeat this step n times. Now let's look at an example. Given that the word is ABZ, and n is 2, that is the number of iterations, number of times you're summing should be twice. Let's analyze it. When for ABZ, the first character is A and its position is 1, that is alphabetically, A is number 1, B is number 2, and Z is number 26, right? Okay. That being said, so during the summation, you sum twice. That's what we said according to this information given here. For the first sum, when n is 1, we see that we sum A, B, and Z, which is 1 plus 2 and plus not 26, but plus 2 plus 6 because of this word given here, digits of the integer, not the integer. Okay, so that gives us the first summation result to be 11. Now we pick this result from the first step or in the previous step to the next summation step, that is n equal to, and do the same thing. Now it won't be, we'll do 1 plus 1, making up the 11, right? And 1 plus 1 gives us 2. That's simply what is required in this case. So the first thing first is always understand the problem or the challenge or the quiz or the assessment. And the second will be you bringing it into coding. That is, first develop. Once you understand the question, develop an algorithm in your head and immediately start coding. And usually you're given about 30 minutes to do this, understanding or even lesser, understanding the question and even providing the answer. So let's start with how we should go about it. So there is it. How do we develop an algorithm for this? We understand what we are required to do. First, given a word S, now let's say our solution should be this: const compute word weight. Okay, I want to use an arrow function. You can use anything of your choice, but I prefer arrow. I do more of arrow function. So let's say the word is this, and let me call it given word so that we won't have any n or iteration, or let's say weight depth. Let's call it weight depth. Weight depth. S will be a string. Should we be doing should this be a TypeScript, we'll use S. We'll state that S is a string and weight depth is an integer. So let's go ahead with this. So first thing we want to do, number one, is create a list of array of array. Okay, create an array or a list. Create a list of alphabets in the alphabetical order. So we need that for what we'll be doing. So for this, there are various ways we could do this. One of them is we could manually say let's computed alphabet let alphabet or computed alphabet equal A. Then we start typing A, comma, B, comma, C. But that will take so much time, right? It will, excuse me, it will take time. Excuse me, sorry. It will take time. So what we want to do is we want to use built-in functions of strings, and let's use built-in function of string dot code point at the function and string dot from code point. So we'll see how to use it here. That's what we want to use to create the alphabet, and that is populate this our list of alphabets programmatically. So we don't need to do that ourselves. So we say let alphabet A equal to let it be equal to, it starts with A, code point at, there is it, code point at it. So that's it, as simple as that. Now we come and say we've gotten the sorry, this will be the code point, alphabet A, code point. It will return a number, as you see here. It will return a number if it exists or undefined. Of course, A exists in alphabet, so in ASCII character code, so definitely it will give us something. So having done this, we've gotten the first character. What we want to do now is use loop to go through it. We say for let I equal 0, start from 0, let I equal 0, and I less than 26, because we know there are 26 alphabets. Okay, my bad. I need to fix this. Okay. So since there are 26 alphabets, we do it 26 times. If you don't know about loop, for loop, and the rest, please read up on it. But I believe it's not a beginner's class, but it's all good. So what we do here is say we bring this, we populate the values we'll get from using code point and from code point into this point. So code point returns a numeric value for this character's position in the ASCII character. And once we know that, what we do there is we say alphabet code point, sorry, computed alphabet dot push. We want to push what we get here. Now string dot from code point. Remember, we have this from code point. Now, what's the code point? We have the first code point to be alphabet A code point, right? Alphabet A code point, but plus I. So what this does is, for the first time, I will be 0. So alphabet A code point will be exactly the code point of A. And for the second time, for the second time, which I will be 1, the code point, we're just adding 1 to that of A, making B, C, D, and so on for subsequent iterations. Now that will return a string value. It is that string value that we are now pushing to the alphabets list or array. So that's once we've done that, we are good to go at that point. What we do next is we compute alphabet in Word. Let's compute alphabet in Word. We need to know, okay, for the word given to us, let's pick all the alphabets in that word, or basically same thing as saying let's pick all the characters. So let word digits equal to s dot equal to the given word. We want to use the given word dot map. Okay, since we didn't state that, okay, the given word should be a string, split. It's usually difficult to work with JavaScript if it's not typed int. Being a TypeScript, so we'll have issues. But basically, since we know that given word is always string, we could do the check, but we are the ones to supply it, so we know what we're expecting. So given word split, we're splitting it. Now we have a map, right? Given word dot split dot map. Let's collect it. Let's say the alphabet or character. Let me just use alphabet. So for the alphabet, we have computed alphabet, computed alphabet dot find index. Sorry, my find index of, let's say, B, where B is equivalent to, where B is very much equivalent to A, or you might say, depending on how you want to structure it, where alphabet is equivalent to what we have, the B we have in computed alphabet, that is that position. We might want to do to uppercase or to lowercase, depending, so that we make it case insensitive. So uppercase. That way it becomes case insensitive. So for the first character, the digits will be 0 if we don't add this +1. You get it? So that's the reason we're adding the +1 to help us handle that, because JavaScript array or list is 0 indexed.